All right. Okay, so welcome everybody. Hello. Let's go back to another stream, right? We are continuing developing our task tracker, right? Which I can show maybe how it works. Actually, it's seg faults because I have to pass some arguments here. Uh, so basically, um, this, yes, what this program does is we have some code, right? So we can, for instance, open the main.c file, and we have some code, and within the code we have some task to do, right? I want to detect root instead of using max depth here, right? So I just create a task in here, and then once I do that, this program, which I'm calling Tatar, or is a task tracker, looks for this directory named tasks, right? And creates another directory there with ID, which is just the timestamp, date and time, right? And within that that directory, it creates MD file, and this MD file has our task. It has the title of the task. It has the status of the task, which is open by default, because once we create a task, his status is open, it's not closed, right? Its priority, the default value is 70, and some description that you can put in here, right? And once your project grows, you can have lots of tasks, like lots lots of tasks. I just have 2 in here, right? But I have another file, which is this one, and I think I have, no, I don't have any here. But you can see, you can have lots of tasks, and it's hard to tell which ones are open, which ones has the highest priority, just by searching or grabbing this in the directory of your project, right? In the root directory of a project. So this application here, it's supposed to do exactly that. For instance, I execute this task tracker, and I put some arguments here. I want to order by date, accident, I don't know how to say that in English, but from the lower value to the higher value, right? So I want to do that, and it will list all the tasks in order of date, creation date. Or I can order by priority, for instance, right? By priority, and it will order by priority. It's not working right now because this is exactly, these filters is exactly what I want to implement today, at least one of them, but that's the idea. And yep, I think we can go right back to the code, and let's start implement it. By the way, this is not my idea. This task tracker, all of these definitions that I just told you, is not my idea. It's idea of a really cool developer called Sodi. So you can please follow him on Twitch. I'm sure you won't regret. It's really educational and really really good software engineer. Yeah, so it's his idea, and I'm just implementing his specs, right? So I think I can even close this. Okay, so let's start implementing exactly this, right? I have some to-dos that I wouldn't bother to create a task, because task is more a thing that I would like to do later, really later on, but not in right now, right? So last time I did this, I just put a to-do here, because next time I will code again, which is today. I will just do that, and I can just delete and do everything. It's not a task per se, it's just a to-do, right? I think I add tasks to a dynamic array. This is more like a task right now, because I don't want to implement it right now. I will implement sorting and filtering today, at least one of them. So I will create a task in here, but not now, because there is another thing. To be able to create this automatically, we have to have an extension in our editor to create that, right? Because it will create the comment in the line. We want to create a directory. We want to create that task.md file with the title and the default values for status and priority. So I don't have this extension or plugin in Vim, but I do have it in Visual Studio Code. I implemented for a Visual Studio Code, so I could, or I will just do to show you how it works. I will create a new task right now. So I made this plugin which adds two commands in Visual Studio Code, which is go to task and create task. If I have one created task like this one, I can just go to task and it automatically goes to that task MD file, which is located in the tasks folder with the ID and with the title and everything, right? So it goes there automatically. And then I can edit the priority. This one is 80, it's not 70, right? I changed this. So I can put some description here, whatever, right? But I want to create a new one, because this to do, I want to make it a task. So I can just execute create task, as you can see here, create task, and it asks me for the title. So in the title will be just add tasks to a dynamic array. All right, so you see it creates the task in here, the comment with the task. It created the directory and the task MD file with the title and the status and priority. So I just save and exit. I can save my main file, and if I want to go back there, I just execute the go to task, and it automatically goes there, right? So it's really convenient. But I just have these plugins implemented in VS Code. I could implement it in Vim today, but I don't want to implement that right now. I remember I did it in the past, but I lost this code. I didn't put in my GitHub, so I think it's in my old laptop or something. Yeah, but I won't implement that. Today I will do so if you go there, yeah, the task is here, so I can delete this to do. I will implement that plugin to Vim, for Vim later. I will implement this sorting and filtering. All right. But before that, I really want to check something, because here, when I compile this, I have a build script, right, to compile this code. Let me create a new tab, and I don't know why I have to do that, but I want to have the terminal here, and I want to show you the build script. It's really simple, right? I have debug information and the output of the name of the program, but I want to put some, warnings, like to display all warnings and maybe even some extra warnings. Because I want to see I didn't mean to quit, but I quit anyways. So let's just a moment. Yeah, so we go there again, we write back. So let's open the build. Let's open, oh my god, yeah, I almost overwrite the thing. Okay, let's execute this, right? We have here in Vim, we have a set make program, which we can put it as our build.sh script. So I just need to execute make, and it will execute that compilation, right? So we have some errors, and we can see the errors in this window here. And yeah, so as you can see, I have some warnings that I wasn't having before, because I didn't have the dash wall and dash w extra. So let's fix this. I don't want any warnings. So it just says unused variable free space. Oh, is that right? Why? Because I remember I was using it. Oh yes, but I'm not using anymore. Yes, yes. Okay, I don't need that anymore. That's right. Yeah, it's really useful, right? To have these warnings. So let's do it again. And now it's complaining about implicit conversion from enum to order type. All right. So maybe I can just put order type. It's like, is that what you want? Order type like that. Yes, it was. Okay, I'm comparing int and size t. All right, because yep, I can convert, maybe I'm not sure if I convert int to size t, because I can lose if this is not positive, but I'm sure that count, it will be always positive because I just increment the counter. Yes, so it always be positive, so I can safely, I think, convert it to size t in here, and that should be all right. Now, okay, I have size t, and it's not d here, it's zu. Now you use the variable t, right? That's all right, because yes, I have to add that to an array. So maybe, yeah, so this is the only one that I have now. No, I have another one here, which is control reaches end of non-void function. That's all right, because I should return something here. How? Oh, because it's free. Yeah, so it's void. It shouldn't return anything because I'm freeing. Yeah, I'm freeing the dynamic allocation, the temporary allocation, I mean. So I don't need to return anything. So now I think, yes, I have this one, and I have another one, which is control reaches end of non-void function again. So let's, what's up with that? We have here some get tasks. It should return a task, but I'm not returning anything. Yes, that's all right. And where do I use it? Where do I use it? It's in there. Yes. Yeah. So I should return this task T in here. Maybe I'm not sure if it will work, because task is a pointer and status is an enum. So this will be copied, I suppose, and this will be copied as well. The pointer will be copied. I think, yeah, so I should return T in the end. Yep. After freeing the content, I should return T. And I think that's it. And I can put like void T in here because I'm not using it for now, to get rid of that warning. So let's see the okay, we don't have any errors anymore, which is fine. So yep, that's really nice. We don't have any errors. I think I have to add this T to an array, but I don't have the dynamic array implemented yet. It's really easy. It's rather easy to implement, but I don't want to bother with it right now. I will just create a list of tasks in the stack. So we have that. We list all tasks here, right? I could even put this in a different function and pass the, I think I will do that. And I will pass the task lists for the function. Like I will create a list of tasks called tasks like that with 256 elements. And this will be and I will zero initialize it. In the future, this will be a dynamic array, right? So I will create a function that is called get task list, right? And I will pass the tasks by the pointer. So this function get task list can modify it, which will add the task list in there, every task. So this is what it's the content of the function. So we have here void get task list, which accepts task by the pointer tasks like that. Then we can do this. Yes. And here we will return anything. We just need to add. I will put account in here. I will just call I. And every time I add a task, I increment the I. So in tasks position I will increment afterwards. I will put T, and that's it. I should put this in here just to make more. Yeah. I think that's it. So now we are having the task list, and I want to see within the main we don't have tasks, right? No, we don't. That's okay. We have tasks in a lot of places, but in main it's fine. We just have it. I'm sorry, I will sneeze. False alarm. Sorry. All right. Let's go back in here. All right, we have the tasks, the list of tasks. What the fuck is that? We don't need that anymore. And so I think, yeah, I am missing one here. Let's compile and go through the compilation errors. Tasks path undeclared. Really? But it was before. All right, I have to pass text. Oh my god, task path as well. So this is a const char tasks path. All right. So now it says passing argument 1. All right, I have to pass another one, which is task. Sorry, now. Yes, I use this. Task path. I'm really sorry. I have to pass here tasks path like that. What else? Let's make it again. It's incompatible pointer type, really. Expected task, but got. All right, so I don't need this. I don't need this. All right, no errors, so we should be fine. Let's just compile and run, right? How can I do that? I can do that like let's run it. Tatter order date x s. All right, it's working. Now I don't worry too much about memory leaking in here because it's a command line application that it executes once, and that's it. So when the program stops, finishes, the SO gets back all the memory that was allocated. So it's fine. Okay, so we have this. Now we should implement the sort and filter algorithms. That's it. That's what we need to do. And that's to do went to here inside here. Yeah, I mean the task, right? The task, not the to do. This task in here. So that's fine. We should now, yeah, let's think about how to implement this, because I have the following arguments: order, and it can be date, right? It can be date, it can be priority, priority, and also it can be those two in ascending order and descending order. So I have those values in here. Order, which is it date or is it priority? I have it in here. And the type, I mean, oh no, it's the opposite. Okay, so I think I can do like this, right? Because I have the order type is the type of the order, which is date or priority, and the order itself, which can be ascendant or descendant, ascending or descending, right? So I already have those. I get those with this function here. I can even show you it's in here, right? It's in here where we do all of this. It's not so big, but it's in here. All right, and okay, we can now, as we have this list, we have the list of the tasks. So if we don't pass any arguments, I should implement that. It's not implemented yet, but if I don't pass any arguments, the order, it will order by priority from, I think it's best descending. So the highest priority is on the top. It's from 100 to 0, right? So the bigger to the biggest value to the lowest value. So I think this is a good default. So let's implement that. Let's make sure that we are having the default values guaranteed. All right. If, yes, I see there, because when we pass an argument, we check if the arguments are correct. Like it's invalid or order is the only argument that it accepts right now. So if we pass something besides the executable, it only accepts this one, dash order. Otherwise you say invalid argument. And if it is order, it should be date or priority. But how can the argument be new? Must inform what order? Oh, all right, I see. Once we pass that, we have to it's obligatory, it's mandatory. If we pass the order argument, it's mandatory for us to have another argument which is only date or priority. I will show you. It's like that. If we do tatter and pass some argument, if I pass some bullshit, some gibberish, it says invalid argument, and it says the usage is this. Tatter, order, it's optional, and after that this is really not optional, this is mandatory. So I will change the use, how can I, where is the, is in there, is it up here? The symbol for mandatory arguments is those ones. And these as well are mandatory. I suppose. It shouldn't be. No, these one are not mandatory because the default one is X ascending. Right? So if we don't pass order, I mean, if we don't pass any arguments, yes, I have to put an if in here. We just get out of this because we already have the default values there. So if argc is just 1, which means we just have the default name of the program, we just return. So because right now we are having a segmentation fault, I think. If we just do that, yes, it's seg faults. And we want to return, right? We want to return. So we just have to compile it again. It compiles successfully, and then now, okay, that's what I want. Because now we are with the default values for order type and order, which is priority and descending, right? So that's it sorted out. We can now start the implementation of the sorting. Let's implement sorting today, and the next stream we can implement the filtering. All right. I think C has in the standard library we have sort algorithms like key sort, Q sort, and we can see, yes, like in here we have some things. But I'm not sure how to use it because we need to shuffle when we are sorting the struct. When we are sorting this task list is a list of tasks which we have here. Where is the tasks? Where is the struct tasks? Task is in here. So I have to sort the array by, it's not the array items themselves, because I have to go inside the item to the title, I mean to the priority argument, member of the struct. So what it says here, qsort function sorts an array with a number of elements, yet the size is this one. The base argument points to the start of the array. Okay, so this is the start of the array, and this is the number of elements of the array, and the size is the size of each element, with which in our case will be the size of the structure, right? And it has more arguments. Oh, we have to implement this compare function. The contents of the array are sorted in ascending order according to a comparison function that we have to implement, pointed to by compare, which is called with two arguments. That points to the objects being compared. All right, so the compare function has two arguments. The first one is the size. What? Oh, it's the item A and item B. the items that are being compared. All right, I think I got it. Let's try to do that. So I will try to copy this. I don't know if I will succeed because I'm inside Vim. Let's try to copy in here using the middle click. Yes, it works. So, right. So I think, let's put it in here like that. I think this one is the base, right? So is the first element, which is tasks path. Oops, is tasks path, like that. Task, it's not path, is tasks, just tasks. Yeah, this is the list, this one. This points to the beginning of the array. That's all right. Now we have number of members, which is all right. I would put 256. I would put 256 because everything else will be 0, I suppose. Let's do that. 256. And size, I think we need to use size of, and we put here tasks. Task, the first element or a element of the task. Tasks. Now we have to implement this compare function, which I will put it in here, like that. I will implement it in a bit. I'll just put here, the name of this will be compare. I don't know, I can change it later. This will be compare. All right. And then I think I need to pass the arguments like this. I'm not sure. I don't remember how to use function pointers. So we can see an example maybe in here. We don't have in here in the documentation, which is always the case. Almost always the case. The documentation doesn't have any examples. Some of them has. But yeah, how to use a C function pointer. I don't remember. As an argument of another function. Yeah, like this. I think I'm mixing some information, right? Because the function implementation is correct, right? I have this, and I have const void size and size. How is it void? I think it's whatever, right? I can put task, because in our case it's a task A and task B, right? Then here we do the comparison and we return something. But in here I have to pass it as a function, right? So I have to pass, oh no, I think I have just to compare. Yeah, just a moment. I'm really sorry. Yeah, because I just have to pass this, because in its implementation of QSort, it has all the information to do that. It has the size of each one, so it has everything. So it's the duty of QSort function to sort this out, literally, right? All right, so that's it. I just need to implement this now. And I suppose what I do is, if A is priority, right? Yes, priority. If A priority is greater than B priority, we should return something greater than 0, I think. And if it's the opposite, if it's this, we should return something less than 0. And if it is otherwise, it's equal, we just need to return 0. I think that's the way we implement the comparison. Let's take a look in the documentation of this beautiful function. I mean, the function is beautiful, but the documentation is not beautiful, because it doesn't give any more information. Yeah, you see, it's all right, let's see, it has more information. So it's sorted in comparison function point by compare, which is called with two arguments that point to the objects being compared. All right. The comparison function must return an integer less than, equal to, or greater than 0 if the first argument is to be respectively less than. Okay, if it's less than, it will return an integer less than 0. That's it. Yeah, because the phrasing here could be simpler, right? The phrasing could be simpler. It's written in a really not so straightforward way to read ones and identify, at least for me, because I'm not a native English speaker, I think. I don't know, but for me it's not so straightforward. But yeah, it's exactly that. If we must return an integer less than 0 if the first argument is less than the second, and we must return 0 equal to 0 if it's equal, both are equal, and greater than 0 if the first is greater than the second. So it is exactly what we have done. If the first is greater than 0, if this first is less than 0, if it's equal to 0. And all right, so we can now see if this is working. We need to have a way to print the lists, but we are already printing. Actually, we are printing when we are getting the list, which is not cool. Yeah, because no, where I was printing it. What? You see, because when we, let's quit this and let's execute it again with the arguments. here we are printing, but I don't like to yeah, I will close this terminal. I think I prefer using wherever, just close it. I prefer to open a new terminal and just go there. It's less key combinations to press to do that, right? So I can increase here and I can just do this, and quickly I can transit from one to another. So we are printing somewhere and I want to where is it? So must inform, invalid, must inform, invalid, invalid. Oh, it's in here. So when we are getting the task, yeah, this was for debugging, so I don't need that anymore. But I want, let's split this because I want to put it somewhere. I will put it in here. So this is here, and this is invalid status. Maybe, yeah, I will delete that. Maybe I don't know if yes, this is an error. So I will print in here and exit. And this is the status. I'll put it in here. And the priority, yes. This was for debugging, but now I can create a function to print. All right, so we can now do, once we got all tasks, we got the tasks lists, we compare them. I will put in here before compare. So this is void and print list, print task list, and I will receive a pointer to the task list like that, and I will do this can come to here. It will be here somewhere, right? And I can, let's iterate through this. I don't have the count, but I will have once this is a dynamic array. Right now it isn't, so I can do count. I know it's 256. I will hard code it for now. There's no problem with that. So we have this 0 when this is less than 256. We increment I, and we easily can do this, right? Then I will call task the tasks. It's really hard to type these tasks, lots of S's like this, and print. I could put like this, so we can maybe easily see where one begins and then another one ends. I think that's it, but yeah, I think once, because we zero initialize these tasks, which means the tasks that are not added, the title will be null. So I wonder how QSort will deal with that, but I think it will deal right with that. But we have to deal with that in here. So if T dot title, if we have, or if we don't have it, if it's no, we just continue. Is that the correct way to say it? We continue. I think that's it. Now we just have to print in here after we sort them. Let's get rid of it and let's print task list, and we pass the tasks like that. And yep, I think it's okay, right? We have some errors. Yeah, because it's not a pointer. I don't know about that. I'm not sure if it should. I think it needs to be a pointer. I think. Let's see. Let's do through here, and I can. Oops, I did some. I don't want this anymore. All right, so we have this compare. Passing 4 arguments of QSort from incompatible, I don't know, pointer type. So it should be a pointer to task. So yes, it's task. I was right about it, and I think I have to pass this like that. Is that correct? Not really. Now I'm confused. Because I see, it should return an integer by a pointer. So this is a pointer, and this is not a pointer because it already returns a pointer. It's not the address, I mean, right? I think that's it. Returning int from function with return. Oh yes, because actually no, it's not that. Okay, let's see the signature again. I deleted, but it's all right. Let's see the QSort help page once more. This is not helpful, right? So okay, so it's a pointer to that compare function. And those should be pointers, but it's not really explicit in here with this symbol. But I'm not sure now. I think this is not it, because we can't really return a pointer. Sorry about that. We can't really return a pointer to an integer if we are just returning a value, right? If you would return a pointer to an integer, we should be accepting this integer as an argument, as a pointer, and we should be modifying it and returning it, or just modifying it, I don't know. We should have to allocate an integer here and return this memory pointer, right, to this pointer there, but it's not the case. Here we just return integers and that's it. But it expects I think this is what it expects. Sorry, I'm really allergic today. It's not good. Let's think about it. If it expects, I mean, this is not what it expects, this is what it's getting. Because if I compile again, it says, yep. Right? If I put some 2 pointers in here, just to mess around, and compile it again. Yeah, so this is what it is getting, but what it expects. Let's see. This is another thing. No, this is in file included from. What? Yes, here it's what expects. All right, so let's do this, and it's getting this. Oh, it's const void. So I think, okay, because it's not modifiable, so if I put some const in here, it will accept. Okay, why I have to put, really? I have to put void in here, and then it's an opaque thing, but now here I can say a, because I know this is a task. and it's important to know that this is a task. Oops. So I will call this a, not a slash, I don't know, underscore. And this will be like a, and b, it is b. Then I can just comment this, and I'll do if, I mean, not if, I would just do this like that. I mean, oh, I'm confused. I'm not confused. I'm yeah, like this, and this is like this. Let's see. Let's try to make it now. Initialization discards const qualifier from point target type. So I mean, maybe we also have to put const in here. It makes sense, actually, right? You knew, oh yeah, that's all right. So this is now, it's this, and this is now this. Is that so? It seems to be. It seems to be it. All right, let's try to do that. Let's compile once more, once again, and let's run it. Let's run it. Let's build, and let's run without any arguments. Yeah, it really didn't work because we have, it's not sorted. It's not sorted because we are printing. Yes, the printing are almost all right. I would put some separator maybe in here, like like this. Maybe once more. Yeah, not too good. I want to get rid of this test directory was found. I don't need that. Too many arguments for format. That's it. You are right. You are really correct, my friend. We don't need this. So let's go. Yeah, so maybe it's I think it's best put this above. All right, /n. I always forgot the new line. All right, so let's do that. All right, so yes, so it's the sorting isn't working, unfortunately, and I wonder why. Let's print it before and after to see if anything changes. This is before, and then we can do like some new lines. We can print some new lines to separate one thing to the other. So let's end, right? And let's do this. All right, so we can go do this. Yes, so this is the first time it executes. So 70, 90, 70, 70, 80. 70, 90, 70, 70, 80. Anything changes. So the queue sort doesn't do anything. Maybe I'm using it wrong. It's from SDDlib. Yeah, and I already... actually, I don't include it in here, and I wonder why the compiler didn't warn me about it. That's really strange. Yep, it doesn't work. That's unfortunate. That's really unfortunate. What's wrong in here? What's wrong in QSort? Maybe, let's go there again. Let's go there again one more time. Let's go to the main page. Let's go to the main page of QSort, and we can check. We can check. All right, so this should be reverse, right? So we don't want reverse. I mean, do we? We do want reverse, but even so, even if it's not reverse, it's not sorting at all, right? 79778. Yeah, it's not sorting. It's not sorting at all. So oh, it has a fucking example in here. All right. Yes, it converts. All right, I see. Oh, all right. This is okay. Yes, so it passes like this. And this is the arguments. This is the number of items. Yes, size of it's correct. It's correct because this is the same as this. As far as I know, it's the same. It's the same thing. And here I have 256 items. And it dereferences it in here. Oh, this is completely wrong because I have to I have to tell the field to sort. I don't know if this is a good. This is not a good naming. I will say AA and BB. So this is AA and this is BB. So priority and priority, and in here, fuck, and in here is priority like that, and I hope now it works. Yes, P, lowercase p. And I think now it works. I hope it works. So let's clean this, compile and build. All right. This is a good thing. So it says that task has no member named priority. Priority. Yes. Do you mean priority? I meant priority. I meant priority. Oh my God, it's working. It's really nice when it works, right? Because here, you see, 70, 90, 70, 70, 80. Now 70, 70, 70, 80, 90. It works. So to do it in reverse, so now it's really easy. Because if I want, right, we have here the order. If order is this descending, we just do this. But if it is ascending, I could do just else because there's no other thing. I just add this reverse thing and I print, and then I print. I don't need that anymore, like that, and I just print the task and it should work. Q sort R. Key sort R. What? Implicit declaration. No, I didn't mean that. I mean key sort R, which is literally what it's saying in here. Am I right? Why? Key Q sort dash R underscore R. Q what? Oh my, why isn't working? It should work. Notes. how to use QSort descending in C. All right, in reverse direction. All right. All right, we change the compare. This is really not good. I mean, because I have to have different compare functions. It's okay, but I wish I could use the R thing. What? Oh, yeah, it's all right. Yeah, I think I need to implement. So this is. I think I need. Yeah. This is compare ascendant and compare descendant, and this will be the same. And I think I just need to call this once and do it in a ternary operation. I don't know if it will be better, but maybe yes. Like I can do is ascending is if order is equal to this. I mean, right, then this is that. If is this, otherwise will be compare this. All right. Then I need to repeat this, but just change the signs. This is really dumb, but whatever. And this is compare this, and this is compare s. Compare s. This is -1, this is 1, and this is 0. That's it. So let's try. Let's try. Let's quit this, clean the screen, compile and run. It's ascending. Now if I do order priority ascending 987 770. Yeah, perfect. And descending is from the smaller to the greater, and ascending is from the greater to the thing. Is it correct? Ascending, this is wrong, it's the opposite. Ascending must go from the lowest to the greatest, to the highest. Oh my god, sometimes the sneezing comes strong. So why is this? Did I do something wrong? Because descending. Well, so this is apparently ascending, and this is descending. So yeah, I think that's it. I think this is correct now. I just switch the names there. because if it's descending, descending, if it's not ascending, that's correct. So if we build and run again, now it's from the lowest to the highest. Lowest to the highest. All right. Now it should be the opposite. And indeed is the opposite. And we achieved our goal of today's stream. I'm really happy with this. I'm not so happy with the way we are showing the information, but we can change that later. We can always change that later. So we are slowly implementing new features, and I'm really happy with this code. It's really simple, and it does what it wants, right? What it should do. It's not overcomplicated, and it's really easy to modify. And yeah, thank you for watching, and see you next time. Bye.